In this example, we plot a parametrized curve, meaning that the variables x and y both depend on a third variable or parameter, t. And we'll plot a tangent line to that curve. So we're going to plot the parametrized curve. X is equal to t cubed minus 3t squared. Y is equal to t cubed minus 3t. On the domain, t is negative 2 to 3. And we will plot the tangent line, after seeing the equation, at t is equal to negative 2. So after loading the symbolic package into Python, we will define x and t as symbolic variables using the symbols command. And then we will define expressions for what I will call xt, for x of t, and yt. We're using xt and yt because we will want to use the symbolic variable x in our tangent line equation. So after executing the command matplotlib notebook, in order to get the graph into our Jupyter notebook, we plot the parametrized curve. For parametric equations, we will use the command plot underscore parametric. So plot underscore parametric, not the regular plot command. According to the help documentation online, the options include the x expression, which is xt, the y expression, yt, and then a tuple for the t domain. So t will range from negative 2 to 3. Now, we're going to follow our strategy for finding the tangent line. We're going to start by finding the derivative using the formula dy dx is equal to dy dt over dx dt. So that requires the Python diff command. So dy dx is equal to diff of yt with respect to t divided by diff xt with respect to t. So the derivative of the yt term with respect to t and the derivative of the xt term with respect to t. Require the subs command in Python. So m is equal to dy dx dot subs, and we are going to substitute t is equal to negative 2. But we also have to substitute t into the x value to find x naught, and into the y function to find y naught. So x naught, or x0, is xt dot substitute, or subs, t is equal to negative 2, and y naught is the yt dot substitute, t is equal to negative 2. Finally, we will define a variable for the tangent line. We'll call it tan line is equal to y naught plus m times x minus x naught. So to check it, we'll print the equation of the tangent line is y is equal to tan line. So we have our tangent line equation. We can plot this equation using the symbolic plot command. But since we are using a different plot command than what we did earlier, we used plot parametric, we can put the graphs together by naming the original plot by naming the original plot of variables such as pcurve for plot of the curve, and then we type that variable name pcurve dot extend at the end of it, and we want to extend it with our new plot command as the option. So we want to plot tan line on the x domain. Our x domain looks to be about from -20 to 0. And then we take our variable pcurve, which has had another graph added onto it. That's what the extend command does. And we want to show this new graph. So we put pcurve.show to show us the new graph. And so we can see, it's a little tricky, but you can probably tell that the curve is indeed tangent at x equals -2, which is way out here on the end.